Article 384.16 At-wo of the 2002 National Electrical Code addresses the overcurrent protection requirements for feeders supplying branch circuit and/or feeder panel boards. The section stipulates that the overcurrent protective device, such as a circuit breaker, must have a rating that does not exceed 125% of the continuous load. In the context of a 200 amp dwelling panel, this regulation directly impacts the maximum size of a breaker that can be installed to feed a subpanel. To determine the maximum allowable breaker size, you must calculate 125% of the panel's ampacity, which in this case is 200 amps. Multiplying 200 amps by 1.25 yields a result of 250 amps. Therefore, according to the 2002 National Electrical Code, the maximum size breaker that can be installed in a 200 amp dwelling panel to feed a subpanel is 250 amps. This calculation ensures that the overcurrent protection is adequate to handle the continuous load without exceeding the panel's capacity, thereby preventing potential hazards such as overheating or fire. The concept of continuous load is crucial in electrical system design. A continuous load is defined as a load where the maximum current is expected to continue for 3 hours or more. National Electrical Code Article 100 provides definitions for various electrical terms, including continuous load. The 125% factor is applied to continuous loads to account for the sustained current draw and prevent nuisance tripping of the overcurrent protective device. This is particularly important in residential settings where appliances and equipment may operate for extended periods. For example, consider a dwelling unit with a 200 amp main panel that feeds a subpanel in a detached garage. If the subpanel is intended to supply power to continuous loads such as lighting or heating equipment, the feeder breaker in the main panel must be sized appropriately. If the calculated continuous load on the subpanel is 100 amps, then the feeder breaker in the main panel should be rated at 125 amps, which is 125% of 100 amps. This ensures that the breaker can handle the sustained current draw without tripping. However, in the specific scenario outlined in the question, the maximum breaker size is limited by the panel's ampacity. Even if the calculated continuous load is less than 200 amps, the breaker size cannot exceed 250 amps, as this would violate the code requirement specified in Article 384.16 At-wo. It is important to note that the National Electrical Code is a comprehensive set of standards that governs the safe installation and maintenance of electrical systems. Compliance with the National Electrical Code is essential to protect people and property from electrical hazards. The National Electrical Code is updated every 3 years to reflect advancements in technology and changes in industry best practices. Therefore, it is crucial for electricians and other electrical professionals to stay up to date on the latest edition of the National Electrical Code. The 2002 National Electrical Code was in effect from 2002 to 2005, and it contained specific requirements for overcurrent protection. While subsequent editions of the National Electrical Code may have incorporated revisions or amendments to these requirements, the fundamental principle of limiting overcurrent protection to 125% of the continuous load remains consistent. Understanding the specific requirements of the applicable edition of the National Electrical Code is essential to ensure compliance and maintain electrical safety. In addition to Article 384.16 At-wo, other sections of the National Electrical Code may also be relevant to the sizing of breakers and feeders in residential electrical systems. For example, Article 220 provides requirements for calculating branch circuit, feeder, and service loads. Article 240 covers overcurrent protection in general, including the selection and coordination of overcurrent protective devices. Article 310 addresses conductor ampacity, which is the maximum current that a conductor can carry safely without exceeding its temperature rating. When sizing breakers and feeders, it is important to consider all of these factors to ensure that the electrical system is properly protected and can handle the anticipated loads. Furthermore, it is crucial to consult with a qualified electrician or electrical engineer to ensure that the electrical system is designed and installed in accordance with all applicable codes and standards. These professionals have the knowledge and experience to assess the specific requirements of the installation and make informed decisions about the selection and sizing of electrical equipment. Improperly sized breakers or feeders can lead to a variety of problems, including overheating, voltage drop, and equipment failure. In extreme cases, it can even result in electrical fires. Therefore, it is essential to prioritize electrical safety and follow all applicable codes and standards. The requirement to limit overcurrent protection to 125% of the continuous load is not limited to residential electrical systems. It also applies to commercial and industrial installations. In these settings, the continuous loads may be significantly higher than in residential settings, but the same principle applies. For example, consider a commercial building with a 480-volt, three-phase electrical system. If the calculated continuous load on a feeder is 400 amps, then the feeder breaker should be rated at 500 amps, which is 125% of 400 amps. This ensures that the breaker can handle the sustained current draw without tripping. In industrial settings, the continuous loads may be even higher. For example, a manufacturing plant may have large motors, welders, and other equipment that operate continuously. In these cases, it is essential to carefully calculate the continuous load and select overcurrent protective devices that are appropriately sized. The National Electrical Code also provides specific requirements for the coordination of overcurrent protective devices in industrial settings. Coordination is the process of selecting and setting overcurrent protective devices so that the device closest to the fault will trip first, minimizing the impact of the fault on the rest of the electrical system. In summary, Article 384.16 At-war of the 2002 National Electrical Code limits the size of a breaker installed in a 200 amp dwelling panel to feed a subpanel to a maximum of 250 amps. This requirement is based on the principle of limiting overcurrent protection to 125% of the continuous load. Compliance with this requirement is essential to ensure electrical safety and prevent potential hazards such as overheating or fire. It is important to consult with a qualified electrician or electrical engineer to ensure that the electrical system is designed and installed in accordance with all applicable codes and standards. The National Electrical Code provides comprehensive guidance on the safe installation and maintenance of electrical systems, and it is essential for electricians and other electrical professionals to stay up to date on the latest edition of the National Electrical Code. Remember that electrical work can be dangerous, and it should only be performed by qualified individuals who have the necessary training and experience. Always follow all applicable codes and standards and take appropriate safety precautions to protect yourself and others from electrical hazards. Consider, for example, a situation where someone attempts to install a breaker larger than 250 amps in a 200 amp panel to feed a subpanel, disregarding the National Electrical Code requirements. This could lead to several potential problems. Firstly, the oversized breaker would not provide adequate protection against overcurrents. If the subpanel were to draw more than 200 amps, the breaker might not trip, allowing the panel to overheat and potentially cause a fire. Secondly, the oversized breaker could damage the panel itself. The panel is designed to handle a maximum of 200 amps, and exceeding this limit could damage the busbars or other components. Thirdly, the oversized breaker could void the panel's warranty. Most manufacturers will not honor warranties if the equipment has been improperly installed or used. In addition to these specific problems, installing an oversized breaker could also create a general safety hazard. It could increase the risk of electrical shock or fire, and it could make it more difficult to troubleshoot problems with the electrical system. Therefore, it is essential to always follow the National Electrical Code requirements and install breakers that are appropriately sized for the panel and the load they are serving. If you are unsure about the correct size breaker to use, consult with a qualified electrician or electrical engineer. They can assess your specific situation and provide you with the appropriate guidance. It is also important to regularly inspect your electrical system to ensure that it is in good working order. Look for signs of damage, such as cracked or broken wires, loose connections, or corrosion. If you notice any problems, have them repaired by a qualified electrician as soon as possible. Electrical safety is everyone's responsibility. By following the National Electrical Code requirements and taking appropriate safety precautions, you can help protect yourself, your family, and your property from electrical hazards. Furthermore, understanding the underlying principles behind the National Electrical Code requirements can help you make informed decisions about your electrical system. For example, knowing why overcurrent protection is limited to 125% of the continuous load can help you appreciate the importance of using appropriately sized breakers. Similarly, understanding the concept of coordination can help you see the value of using coordinated overcurrent protective devices. By taking the time to learn about electrical safety, you can become a more informed and responsible homeowner or building owner. You can also help to educate others about the importance of electrical safety. Together, we can create a safer environment for everyone. Remember, electrical work is not a do-it-yourself project. If you are not a qualified electrician, do not attempt to perform electrical work yourself. Hire a qualified electrician to do the work for you. This will ensure that the work is done safely and correctly. It will also give you peace of mind knowing that your electrical system is in good hands. In addition to hiring a qualified electrician, it is also important to obtain the necessary permits for any electrical work that you are planning to do. Most municipalities require permits for electrical work, and failing to obtain a permit can result in fines or other penalties. Obtaining a permit also ensures that the electrical work will be inspected by a qualified inspector who can verify that the work has been done in accordance with the National Electrical Code requirements. Finally, it is important to keep accurate records of all electrical work that has been performed on your property. This will help you to keep track of the electrical system's history, and it will make it easier to troubleshoot problems in the future. You should also keep copies of all permits and inspection reports. This information can be valuable if you ever need to sell your property or make an insurance claim. Electrical safety is an ongoing process, not a one-time event. By following the National Electrical Code requirements, taking appropriate safety precautions, and regularly inspecting your electrical system, you can help to ensure that your electrical system is safe and reliable for many years to come. And remember, if you have any questions or concerns about electrical safety, do not hesitate to consult with a qualified electrician or electrical engineer. They can provide you with the expert advice and guidance that you need to make informed decisions about your electrical system. Let's delve deeper into the concept of continuous load and its implications for breaker sizing. As previously mentioned, a continuous load is defined as a load where the maximum current is expected to continue for 3 hours or more. This definition is crucial because electrical equipment, including circuit breakers and conductors, generates heat when carrying current. The amount of heat generated is proportional to the square of the current. Therefore, if a circuit breaker is subjected to a continuous load, it will generate more heat than if it is subjected to a non-continuous load. This heat can cause the circuit breaker to overheat and potentially trip, even if the current is below the breaker's rated capacity. To prevent this from happening, the National Electrical Code requires that overcurrent protective devices be sized at 125% of the continuous load. This provides a safety margin to account for the heat generated by the continuous load. The 125% factor is not arbitrary. It is based on extensive research and testing that has been conducted by electrical engineers and industry experts. This research has shown that this factor provides an adequate level of protection against overheating and nuisance tripping. In addition to the 125% factor, the National Electrical Code also provides specific requirements for derating conductors that are subjected to continuous loads. Derating is the process of reducing the ampacity of a conductor to account for the effects of heat. The amount of derating required depends on the type of conductor, the ambient temperature, and the number of conductors in a raceway or cable. The National Electrical Code provides tables that specify the derating factors for various types of conductors. When sizing conductors for continuous loads, it is important to take these derating factors into account. Failure to do so could result in the conductors overheating and potentially causing a fire.